Parallel, antiparallel, and perpendicular vectors. All right, let's start with this vector right here. I want to make a copy of this vector right now. So here I have an exact copy of this vector. You can see I put them over each other. There we go. Perfect copy. And as I move this vector around, it's always pointing the same direction. Doesn't matter where I put it. It's the same direction. That makes it parallel to this original vector. Okay, so these two vectors are parallel. And it doesn't matter where I put it in relation to anything else. Right there, it's still parallel to that original vector. Right there, still parallel. It doesn't matter. What matters is the direction that it is pointing. Okay. Let me go ahead and put it so it's just coming straight out of the origin. The way we can tell if two vectors are parallel is if they have the same angle relative to some reference, so like the vertical or to the horizontal, and if they're both pointing in the same quadrant. So here, with this vector, for example, let's just make up some angles. I'll say that this angle is 30 degrees. It's 30 degrees to the horizontal, and this other angle right here, 60 degrees. So if I find another vector that's pointing up and to the right, and I know that its angle to the horizontal is 30 degrees, then I know that vector is parallel with this one. If I find a vector, it's pointing up and to the right, in other words, in the first quadrant, and its angle to the vertical is 60 degrees, then I know it's parallel to this vector. Now, antiparallel is the exact opposite direction. So an antiparallel vector is going to be pointing in the exact opposite. There we go. These two vectors are roughly antiparallel. I only say roughly because I was eyeballing it. But if they're truly antiparallel, the angles to the horizontal and vertical should be the same. So in other words, this angle here, which is to the horizontal, that should be 30 degrees. This angle here to the vertical, that should be 60 degrees. The only difference between these is the quadrant they're pointing in. This one is up and to the right, so it's in the first quadrant. This one is down and to the left, so it's in the second quadrant. So that's what makes them anti-parallel. Now for perpendicular, if I want to draw a perpendicular vector, let's make it green actually. Okay, here we go. So, and I'm eyeballing this, but that looks pretty close. Okay. Let's say that this vector is perpendicular to both the red one and the blue one. Okay. So or perhaps it would be better to say the red and the blue are perpendicular to this green one. Okay, well, in that case, what does that mean? That means the angle, if I start at the green one and I go to the red one, this angle has to be 90 degrees. If I'm going from the green one to the blue one, well, this angle has to be 90 degrees. Now, just to label these, instead of just identifying them by color, let's say this is vector A, okay? And then I'll say this is vector B, and I'll say this is vector C. So I am saying that vector A is perpendicular to B and C. And what does that mean? That means the angle from A to B has to be 90 degrees. Well, I already know the angle from B to the vertical is 60 degrees. So that tells me right there that this angle here has to be 30 degrees. 30 plus 60 is 90 degrees. Down here, I know that I'm saying A and C are perpendicular, so the angle between them has to be 90 degrees. This angle is 30, so to get 90, this here has to be 60. So there are some patterns to notice here. First off, if it's perpendicular, the perpendicular vectors can't be in the same quadrant as my given vector. Okay, they have to be in one of the neighboring quadrants. Can't be in the opposite quadrant. It has to be in one of the neighboring quadrants. Okay. Additionally, of course, the angle between these perpendicular vectors has to be 90, but notice that for two vectors that are perpendicular, the angles to the same reference, so in this case the vertical here, the angles to the same reference add up to 90. Or down here, the same reference as the horizontal, so these add up to 90. The angle here to the horizontal is 30, the angle here to the vertical is 30. So we can also see some angles that are the same, but they're different references. This one's to the horizontal, this one's to the vertical. But the key idea here for the perpendicular is it really helps to draw the vectors so you can identify the angles, the necessary angles, so that when you're looking at what vectors might be perpendicular, you can identify which ones are. It helps to draw. So if I was to say anything, stress anything for any of these vectors when you're comparing them, it's drawing them. Drawing vectors is so crucial, especially when you're learning vectors.